So, are there degrees of intervention when it comes to Everest? Like, for example, out on a job site, can the robot itself figure out how much needs to be excavated in a certain area and go do it? Or do you have to dictate exactly how much has to be excavated at each point on the job site and the speed of it and all that stuff? Is there how much manual intervention is really needed?
Not much. So just like any other construction project, if you have a human operator, someone needs to tell the human operator what needs to be built, right? So, hey, you need to dig a trench from point A to point B. I need that trench to be 3 feet deep, and I need the material to be put 3 feet to the side. That's it. Um, that's exactly what you would tell the robot. You would tell it where you need the trench, what you need the trench to look like, and then you press go. That is all the, I guess, instruction that the robot needs. There's no intervention necessary because the robot will then figure out, okay, I've been given this task. The robot will survey the Earth on its own and figure out what does today's world look like? And then what do I need to do to turn today's world into what the REO told me to do? And the robot does all of this planning on its own. And so it'll figure out this is how many scoops I'm going to take. This is how I'm going to approach the dirt. This is the angle my bucket's going to be at. As it's digging, it's also replanning and it's updating its plan and saying, wow, I'm getting a little more resistance from the dirt than I expected. I should change my bucket angle and I should attack it a little differently. All of that is being done on its own by the robot. And
Oh,
that's what
wow.
our software, it's very powerful. It's able to react to a very dynamic environment. Um, and that's actually one of the cool distinctions actually about our technology is that unlike self-driving cars or even self-driving trucks, um, what we're doing is essentially manipulating our environment, right?
Yeah.
The excavator actually digs and it's actively changing everything around it. And so unlike in self-driving cars, you're driving on a road, you are not trying to interact with the road at all. If you interact with the road, it's probably an accident, right? And so that's kind of the unique nature of what we're doing, which is there's autonomy and automation, but there's this kind of manipulation of your environment. That's the robotics piece of what we do. And that's why it's really cool intersection that we
And what's
find ourselves in.
more difficult to me is that each job site is different. Soil
Yeah.
conditions are different. And even within a particular job site, some areas can be rocky, some areas can be clay, sandy. It's just there's so much more unpredictability, even though the site is more confined than large stretches of a road.
That's a great observation. That's exactly right. And I would say that a lot of people compare construction to mining and agriculture, the sister industries that have seen probably more automation
Yes.
than construction to date. And I'd say one of the biggest variables is what you said exactly, which is construction projects are shorter in duration. Maybe they're 6 months or 12 months, but once you're done, you move on. You go to a different site and it could be totally different conditions.
Yes.
Whereas a mine, once they build that mine infrastructure, it's there for 25 or 50 years and you can just keep working in the same area. Now, of
Or
course,
even with agriculture, it's seasonal or yearly again, they're working within a certain area year after year.
correct. There's
Yeah.
some element of permanence.
Yeah.
I'll concede that agriculture and mining also are fairly
Yes.
dynamic because you are manipulating your environment. But I'd say construction is the most dynamic of all of them. And so for that reason, we think that this is actually a very complex software problem. And that's why, we spend a lot of time developing and honing this really powerful software that we've created.